Aaron Tuttle here. It's storm season in Oklahoma, and with that comes torrential rain, high winds, and hail. To protect your home and your family from these threats, the one roofing company you should trust is Ferguson Roof Systems. They've been providing the best in roofing services for nearly half a century. Ferguson is Oklahoma's full-service roofing company, certified with an A+ Better Business Bureau rating and a 5-star rating on Google. And with Ferguson now offering Class 4 impact-resistant shingles, now is the time to trust them with your home's roof. Get started today at FergusonRoofSystems.com.
Hey everyone, Meteorologist Aaron Tuttle with you. It is Sunday night, a little after 9:30, so we're going to get crack-a-lack in here on this broadcast. Find out what has changed in the weather data, if anything, for the storm event that's coming in for Monday. There's been a lot of talk about it here over the last week, I guess, last several days. So I don't know who says what, just so you know. So I don't know what has been talked about. I can tell you what I've been talking about, and that's the fact that, as always, I wait till about 48 hours out before I ever talk about tornadoes, just because too many things can change. The primary reason for that is storm systems that come in, over the water of the ocean aren't really sampled well, about our balloon sounding network. It's all based off of satellite, and satellite does a really good job, but that inputs the model data. But we really fine-tune things is whenever we get those balloon soundings in. So once it gets onshore, across California, etc., so we get to sample the storm a lot better, and then we get to feed those in our higher resolution models, and that can help to spit out the intricate details that we need to even talk about tornadoes. So that's why, again, that 48-hour rule is what I like to go by, because I don't lead you astray and get you all worked up for nothing, right? So in the meantime, what you can do, what the science allows you to do, is to say a general trend. So I mentioned this Saturday night in my live. Somebody asked about the Storm Prediction Center, not doing so well or whatever. As you misinterpret what their purpose is. Their purpose is just to give as much heads up as possible over a geographical area that there may be some severe weather. All right, because their clients are vast, right? Their energy sector, other government agencies, etc. So it's basically a planning thing. Where that has gone awry is when you get storm chasers or you get the TV guys take that and then use it to then hype up a big event and start talking about tornadoes, though they're certain, and how much of a risk there is so many far days out. The problem is this is all a probability game. And you'll understand when you see these Storm Prediction Center, and I'll show you some graphics here, we're talking like they put 2%, 5%. We're talking probabilities this tiny. So to scream 2% chance all week long, is silly. So you have to understand how that's kind of changed and just it's frustrating. So whatever. So what I like to do is ignore all that stuff, and I just kind of tell you whether or not, if there's a general setup, and then, we'll get, as we get closer to it, we'll nail down the details, because it can always change in timing or track and all that kind of stuff, and that changes the output. It's no different than snowfall forecasting. Snowfall's the same way, 48 hours. Beyond that, you can go from a foot of snow to dusting just like that in the data in no time. So severe weather is no different. The closer we get, the better it is on the accuracy. Everything else, ignore. Just put in the back of your mind, going, oh, there might be some storms, on Monday. Okay, well, I'll tune in Sunday, right? Or I'll tune in Monday to get the specifics, because it'll change 10 times between now and then anyway. So that's how I would view it. So that way you don't get anxious and worked up over it for 6 days in a row. All it's going to do is make you lose your hair and put on some pounds. Who wants to do that? Most people don't. All right, let's take a look and see what's going on out there currently. It was so warm today. Oh my goodness. I got 79 out there now, so now it feels pretty good. This is on my Tempest weather station. You can pick up one of these as well. I got the QR code there. You can scan it anytime on your mobile device. You can also type in the promo code TEAMAT and save yourself a few percentages on that. By the way, thank you guys for tuning in on Rumble tonight, also on YouTube. As always, got the same group in the house, always commenting. Appreciate that. Lets me know you're out there. Same thing for Facebook, and tell me where you're coming in from. And also for the stars, I already see many of you have done that already. Robert, constant star sender. Same thing with you, Mr. Anderson from the Matrix. Crystal also send me some love in that fashion. Mary as well. You don't always do that, by the way. If you just want to send me some love by just hitting the like button or subscribing, trust me, that works too. I appreciate everything you guys can do, because this is all organic, right? So let's take a look. Let's get into the weeds. So this is the midday severe weather outlook from the Storm Prediction Center. So what they have here is an enhanced area up here and then down in here. That's what that means is they're looking for those two kind of favorite areas for potential for a little higher probability of seeing some storms in those areas as far as coverage is concerned. When you look this at the tornado risk, it's a 5% ring across this entire brown shaded area. Tornado probability legend here in the bottom, 2%, 5%, 10%, 15, 30, 45, 60, significant. How often do you see 45, 60 or significant? Very rare. How many outlooks are put out there where you get a 2 or 5? A lot. So that's not saying a whole lot. Wind, highlighted here across this large area, and also for hail in 2 spots here as well. Now, again, keep in mind, does not mean this is a guarantee that we'll even get a storm anywhere in this area. All right, so let's take a look at what the algorithms say. What about the learning machine language, the AI? What is it doing? It's chicking it out on this whole deal. It keeps getting lamer and lamer each run. So it's split into 2 areas, a little 5% ring of its own up here across Nebraska and the northern half of Kansas, and also this little sweet spot down here in northwest Texas, maybe back into far southwestern Oklahoma. That's for the tornado probability. This is for the hail, kind of the same area, and also for the wind, kind of in the same area. So you can see that kind of jives a little bit with the Storm Prediction Center as well. Okay, if we do look at another AI platform, this guy's called NATOcast. So he's been running this for a little while on Twitter and kind of fine-tuning it with time. If you were to look at what he calls the significant tornado, when they have calibrated everything, it kind of highlights one little sweet spot here in southwest to south central Kansas, a couple of areas up here in Nebraska along the warm front, an overall very light shaded area here in gray, but that's like a 1% probability. So even this model is struggling to try to produce tornadoes given the environment. Weather Service, here's a close-up view from the Storm Prediction Center, but from the National Weather Service graphic. Low potential for tornado, up to baseball-size hail, 60 mile per hour winds. Again, they highlight this area. I think this is all going to be an error, just so you know. I can be good with the entire slight risk across the state. I really don't see a reason for the enhanced, but usually once they go enhanced, it's hard for them to pull it back. But we'll see what happens when we look at the data. They'll probably wait till tomorrow morning to make that decision. Here's a look at the tornado potential. Again, they have it on the low side, but honestly, this whole map could just be, if I had to do it, I mean, you could really just do this whole thing, all right, all of Oklahoma in a low to very low is how I would look at it. All right, on the Weather Service for Tulsa, golf ball size hail, limited is what they call it for a potential tornado. Also some wind, and they're keeping it here. Notice, by the way, this green area. So on Tuesday, just so you know, Tuesday afternoon and evening, this is your favorite area for severe weather, but quickly ending. So in other words, earlier in the afternoons, like mid to late afternoon, their threat keeps shifting farther to the south and east. So model forecast soundings do indicate you might break the cap in this area. Again, all hazards possible with a little bit of wind, a little bit of hail, and possible tornado. So keep that in mind on Tuesday since everybody's talking about Monday. Okay, so here's a look at the upper level storm system. Where is it at? Right here, dead center over Colorado. The problem is from earlier, several days ago, it had the system right about here. Right? Well, here is not here, and here makes a big difference from here. Here also is around 7 o'clock tomorrow, whereas here is 7 o'clock tomorrow. So the system is too little too late. It's 6 hours behind, and it's several hundred miles back up to the northwest. And so that changes your outcome completely. But again, what it does favor, as I had mentioned in a post a couple days ago, is it does kind of favor this area, but it's closer to the dynamics and the cooling and the shear as well, aloft. So that's why sometimes you get better storms there, because you get a warm front, et cetera, et cetera. So let's take a look at the wind field at 300 millibars. This is the jet stream zipping through. And right now, because the way that storm system is coming out, it's kind of anchored with the core of it off in this direction. So it needed to be in this direction. So we're kind of on the far edge of it, which doesn't really do us much good if you really want storms. Let's go to midnight. In the midnight hour, the core is still up into this region. We're finally getting a little bit of a taste of it. We're not exactly in the right quadrant for it aloft. So we already have one negative factor there. It's not a huge factor. It's a subtle one at that height of the atmosphere, but needless to say, it's not ideal. If we look at, again, if you want storms, if we look at the 500 millibar patterns, this is our jet streak that comes in. So it's late. It's way over here by 7 o'clock. Let's go to midnight. So midnight, didn't move much. It's now here. So at midnight, we should have, and I'll show this here in a minute, but we should have our dry line cold front kind of in this vicinity. So it may try to help to fire off some storms there as everything moves in. Let's go 3 hours more. And there it is moving now through central Oklahoma at 3 and 4 o'clock in the morning. So it's a little late, but we'll see what it can do. If we look at the 850 millibar jet, the low-level jet that comes in at 7 o'clock, good strong southerly jet here. So that's good if you wanted storms, because they like those strong south winds feeding into them. If you look at the midnight hour, that still continues. Got a good south-southwesterly flow, some very strong winds. Let's go to one more. Yeah, let's go to 9Z. Yeah, because this is where you can really tell the influence of the Pacific front coming in, because now our winds are shifting around to the west. So what happens is with storm systems, the dry line that's out there gets overtaken by a Pacific cold front that'll form as that upper low starts to move out. So here's a look at the dry line as we speak of. This is around 7 o'clock on Monday. So we've got something that kind of anchors like this. Now, if you may have noticed in the past, the dry line continues to shift a little bit more to the west. So it's basically setting up right across Amarillo. And what you do is you get storms that fire just on the east side of the dry line, and then they mature like a couple of counties over. It's usually how that works out. Now the big dews, 70 dew point for example, is all the way up here to Dallas, Fort Worth, and down southward. Whereas Oklahoma, we've got mid 60 dew points. So mid 60s is pretty good. Here's maybe a pocket of upper 60s. But in the atmosphere, unfortunately, for Monday, we'll see if this. I haven't looked at this data yet. It's just coming in, so we'll look at it on the fly. This is a monster cap. It's so funny. I had somebody comment, I guess, on one of the meteorologists. It says, "Don't listen to Aaron Tuttle. There's no cap. He doesn't know what he's talking about." Of course, the dude's not a weather guy by any stretch of the imagination, but it's cute. He's got to sing his loyalties to his favorite weather person. But you can tell him to come look at this. This is a monster cap here on the high resolution NAM model for Oklahoma City. We see this big departure. It looks like a Christmas tree, right? So this is the red. This is the temperature profile. You see how it nudges way over here to the right? That's like 20. What is that? 22 degrees centigrade. Whew, that is warm. In other words, you can't get storms in this environment. That's what it means. It's a lid. It's an inversion layer. No dice. No storms. So yeah, that's the atmosphere we have over the body of Oklahoma is a very strong cap. So you can only erode that cap a couple of ways. You can brute force it from convergence along a dry line. So in other words, you get a southwest wind here and a southeast wind here, and those winds come together. They can't go down, so they must go up, and they keep going up, and they keep going up, and eventually you can bust the cap. So that's one way. The other way is you cool it down, that layer of warm air, from the west. In other words, the system comes east, it brings in cooler air with it, a couple thousand feet off the ground or so, and that cools it down, and the cap erodes, and then you can get some storms. So that's the question that's going to be on the table here for tomorrow night. Because obviously during the day, that ain't happening, right? So we won't get storms during the day. But we will get some rain during the day. I'll show you that here as well. Okay, by the way, let's zip this through. I want to go to midnight here. Let's go right here. All right, midnight, the dry line is finally on the move right here. And the winds are picking up stronger. So what we're really starting to mix is, because we'll get a little bit more of a northwesterly component a few hours after that, was really turning this into a Pacific cold front. It's really what's going to do, which is a little bit more forcing than just the weak little dry line, since it's now on the move at nighttime. Because otherwise, dry lines don't move east during the night. Just so you know, that's a diurnal thing with the sun, etc. So this is being forced movement now from synoptic events. Let's go 9. So about 3-4 o'clock in the morning. Yeah, so the front is still off in this vicinity. We're getting a little bit of a southwest flow here ahead of it, and a south wind here. So in other words, we don't have any good convergence along this boundary, and you really need convergence along boundaries to get air to rise to produce some thunderstorms. So that's a negative going in for tomorrow night. This is why the models are really struggling trying to produce any storms at all, just because we don't have good convergence, even though this is a good pushing edge of a cold front, which will bring colder air aloft. And that's why I kind of struggle with the output. I'm like, come on. I said, models, come on. You can't get any storms to go. You should at least get something. So let's take a look here at the instability. So during the afternoon, you got some pretty good shear out here in western Oklahoma, in the northeast Texas Panhandle. Cape Valley's up around 3,000. I'll just pick a forecast sounding up here just to show you. So in this particular case, you would have a possible hazard type of a tornado, some large hail up to 4 inches in diameter. So that's some big hail if a storm were to go. You do have a little bit of a cap here, but it's weak. It's underneath 25 on the SIN. Therefore, the dry line should be able to break it. All right. So even though the models aren't producing storms out here, I still think we should be able to get something, at least up in this part of the state, that moves quickly into Kansas. That's kind of a favorite area. And also down here into northwestern Texas was kind of like my second area. Let's go on into the midnight hour, see what happens. Now, the midnight hour, we still have some instability out here, but it's dropping because we lost this daytime sun, right? And if we look here at Oklahoma City, I'll just put a forecast sounding there to kind of give you an idea. What's happening in our neck of the woods? Well, we still have that cap here. All right, it's lifted some and eroded some by hair, but otherwise it's still there. So in other words, this would preclude surface-based storms from developing, and you'd have to have something already coming in from the west that was already surface-based to be able to ignore that and still feed in. And if you look at the conditions out there in far western Oklahoma at the midnight hour, there's just a teeny tiny bit of a cap, which really should have no problem breaking with a moving frontal band to kick storms off. Hail size up to 4 inches in diameter. Again, this is at midnight, by the way, out here in western Oklahoma. And if it were to produce a tornado hazard type, EF3, EF4 is listed. Now, obviously, that's a little concerning, right? Because the parameters say if you could break the cap, which they indicate the cap will weaken at this point out here in western Oklahoma, we should get some thunderstorms. The models do not produce thunderstorms. So there's something they're seeing that the data says that they shouldn't be seeing. So I'm not sure what's going on. And they all do this, except for I think one. And we'll show that one here in a second. All right, here's a look at the significant tornado parameter. All right, this is where you have the best ingredients for the atmosphere for tornadoes to develop. Well, at 7 o'clock, a little bit highlight out here along the dry line, the panhandle, little sweet spot up here, like I said, in northwestern Oklahoma to Kansas. Let's go to the next one. By late evening, and there's a little bullseye out here in western Oklahoma, which I showed you the forecast sounding for at midnight. So again, if we can get a storm in this environment, it should not have a problem producing a tornado. The question is, why is there no storms? All right, let's go to the 3, 4 o'clock in the morning hour, I-35 corridor, but the numbers are coming down. This is a 2.4. Earlier it was a 5. So that's because we're cooling things down, right? So here's the 12Z, which is Tuesday morning. It's even lower and shifting on north into Kansas. So that means Kansas stays favorable overnight for tornadoes, whereas Oklahoma necessarily does not. It keeps diminishing. Okay, so now what else we got for you? Well, let's take a look at the cap. All right, so this is the SIN. This is another way of viewing it. I showed you the vertical profile. Looks at a flat picture. All right, the brighter the colors, the stronger the cap. This is a 400, 500 joules per kilogram in the negative side, so this is monster cap. When you get out here where it's just like white, that means there's no cap at all. And interesting enough, at 7 o'clock, it says there's no cap out here. Let's go to at 9 o'clock. Cap builds back in as usual. That usually happens right at dark. Still strong elsewhere. Okay, let's go to 60. So this is midnight to 1 a.m. Again, this is a little sweet spot out here where the models say the cap will break. This is the indication of the front now on the move. So in theory, you should be able to develop some storms out here is what you should be able to do. All right, let's go to the next one. All right, now that cap is eroded, and this is why it's because cooler air has come in behind this system that's working out ahead of the front to help cool things down, and that's going through the I-35 corridor during the overnight period. Okay, so we know the models are suggesting the cap erodes. So what do they do with that? Do they produce thunderstorms? Let's take a look at that high resolution NAM model. So first off, we're going to have some rain. Let's see, what time is it? It's about 10 o'clock in the morning. See these little light showers moving through central southern Oklahoma, through Tulsa, Oklahoma City. So off and on, sprinkles, clouds, and you know what that means. Typically that erases the threat of storms. Yes, because it cools the atmosphere down to the surface where we live and breathe, and so our ground temperatures, instead of being 80, are like 70. Well, you have to heat the ground to get the cap to break, and that's why we have monster cap. So again, thanks to the rain, it's going to hose us if you were wanting storms. Now, up in Kansas, like I said, things a little bit different. Kind of tiptoes into the northern county, almost of Oklahoma. So at midnight, we have a nice little signal here for some thunderstorms here in the southwestern Kansas. And a forecast model sounding up here does show some trouble. You do have a low condensation level, 71 degrees over dew point of 67. A very weak cap right here, which is so weak that it should be easily broken. Still has the potential for a tornado on the high side. So again, in southern Kansas, again, you'll have to kind of watch things. Make sure you have your NOAA weather radio on. Make sure you have my weather app, AT's Weather to Go. It's free. You can get on Apple, Google Play. It'll predict tornadoes. But regardless, that's what happens in Kansas at 1 o'clock in the morning here in Oklahoma City. Looks like there's a couple of showers and model tries to get going. Again, this is nowhere even near the dry line / Pacific cold front. And we still have a monster cap here. So what that tells me is trying to develop right here some elevated thunderstorms. Now, elevated thunderstorms can produce some hail. With this particular case, the Cape is only about 1,500. So your hail sizes won't be out of control crazy. Let's see, the ship model is 1.4. So the ship model need to be 2 to get really larger size hail. So, when you hear the forecast of baseball size hail or larger, it can't happen unless those storms are rooted in the boundary layer, aka the cap did not prevent them from feeding off the surface. All right, so let's go to 2 o'clock. Well, those things raced off to northeast, which means they're not rooted. They're already passed through Tulsa, which means they're not surface-based storms. So I might have a little small hail with them. That's about it. Some other light little thunder showers popping up here along the I-35 corridor on the east side from Ponca City to Stillwater out towards Shawnee at 3 o'clock in the morning. There's 4, there's 5, there's 6, there's 7. I mean, there's no storms. Remember we had the front that was supposed to come in here? It didn't produce any storms either. All right. What it did do, though, we talked about, was cooling things down. Let's take a look at temperatures. Let's go into Monday. Here we go, during the day. All right, so there's 2 o'clock. Again, we'll start to have the rainfall and the cool air from this region here will advect north and west. So I kind of take over and kind of cools things down. So there's 4, 5, 6 o'clock. Notice how we're dropping now, 70 degrees. Still a little warm out here in western Oklahoma, but not warm enough. I mean, we're in the 70s. So if it was in the 80s, it'd be a different story. But we're not in the 80s. We're in the 70s. Okay, so let's take a look at the HRRR, another high-res short-term model, see what it does. We've got the rain down south. Okay, so it does produce a couple of, 2 things we'll talk about. First is, it does have some thunderstorms down here in northwest Texas, like I mentioned. This is right about the Wichita Falls area. The forecast sounding down here indicates still a little bit of a cap, though. All right, so the strength is pretty high. So these will probably be elevated thunderstorms. There's some decent shears. You probably have some decent hail with this because Cape Vibes, like I said, are a little high. So those are probably hail makers and wind makers down here. There is a low risk for a tornado, but it's just not very high just because of that factor. Not out of the question. It's one of my areas. The last couple of days, I told you here and here was where I was kind of focused on. So I'm still going to keep that for the south. This one, it may be a little bit more into Kansas, like in here, but regardless, it was pretty close. But if you do see in Kansas, up from there to Nebraska, you'll see the generating of thunderstorms up here along the warm front. So let's go to the evening hours. Let's see, there's 7, 8, 9 o'clock. So there's some more thunderstorms developing there across Nebraska. And then here's that little cluster here in central Kansas on this particular model through midnight. And some of these, again, could be producing tornadoes. For Oklahoma, for the HRRR, let's see, at 3, 4 o'clock in the morning, it does have a little activity here that's building up. And this was one of the things I thought was interesting in this particular model. It actually had completely eroded the cap as well, and it actually did produce some showers and thunderstorms. And a lot of the indices here says, well, we should be getting tornadoes out of it, at least, and it has like an EF2, possibly EF3. It has, again, no cap, still decent Cape values, and a really kind of a decent looking overnight temperature profile. The shear, it's a little veered here at the surface, and maybe that's what's going on with the model, because given this situation, it does not produce any supercells. And I thought that was really strange. Normally, I would have expected the model to do that, because this is a model that's supposed to be able to do that. So let's zip in. And you see how they're all just broken up in these teeny tiny little cells? This looks to me like an elevated popcorn multicellular pattern in the data. So in other words, not supercellular, not indicative of any significant large hail or any significant damaging winds, and definitely not a tornado. So now I'm strike 2 on our best models to be able to find this stuff out. And so when I was reading my blog earlier today, I'm sitting there scratching my head going, what is going on? If we're going to be, providing the ingredients to have some type of supercells overnight, why are these models that are supposed to be producing them not producing them? So I had to go to the couple of these other ones. Let's just look at them real quick. See what they do. This is all just came in this evening. So this is the WRF here. Let me see. So it's got the stuff in northwest Texas. Okay. It's got one little guy that crosses over the border here in the southwest Oklahoma around 8 o'clock. Looks pretty meaty, but it's moving kind of a northeast pattern. Typically that means it's kind of a left mover type deal. You get a little bit of a large dew point depression here. It's kind of a high cloud base. So with this, it's struggling to keep what it was probably doing in Texas. So I don't think it'll be able to produce a tornado. If you go to the next hour, it falls apart because it's getting into that rain-cooled air. So if it were to do something, it would have to do it probably just as it's crossing over the border, because then immediately after that, it goes into an environment that's not favorable. Then these guys over here start heading up toward Dallas-Fort Worth, and they start to lose their steam as well by 9 o'clock. So if you're in Dallas-Fort Worth, same deal. You don't really get hit by anything for tomorrow night, but you do potentially on Tuesday. Depends on how far that front makes its way into your area. You might have some redevelopment, or maybe just east or southeast of you. So just keep that in mind if you live down there. Otherwise, let's go on to the next one. Let's go the NSSL. Old school. What does old school do for me? Same thing. Little stuff down there in northwest Texas. Stuff up there in Kansas. And nothing in between. Got a couple things popping up here around Tulsa around 4 o'clock in the morning. Those quickly moved into Kansas. No helicity tracks at all with those. Again, helicity tracks are those little lines we'll see on the map, which usually indicates either damaging wind, hail, or tornado path, little core, and that's not there. All right, let's go to the supercell maker. This thing produces supercells. It's almost like no matter what time of the year, it'll put supercells on the map. So if you want a supercell, this is the model you go to. Let's see what it does. All right, so it's got the ones down here in northwest Texas. By the way, just so you know, I usually discount this model because it always produces supercells. It's dumb. It's hardly ever right. So I don't put a whole lot of emphasis on it. All right, so it has a little cluster of storms down here in North Texas that fall apart, and just comes a big old heavy rainfall during the first part of the evening. And then after midnight, it does produce some new development here that moves through Oklahoma City and down here around the Ardmore area. See what the forecast sounding is at that point in time. Again, it has most of the cap eroded, not quite, just about all of it, but a very high cloud base as a result. Marginal risk for a tornado here with that one for Oklahoma City. Shear doesn't look all that great at all. If you look down here along the Red River for this guy, same thing. It's still got a little bit of a cap here. So again, elevated, just has a severe storm, no threat of a tornado. So even this guy who loves to produce supercells is struggling. All right, then it turns into a multi-cell hybrid cluster of nonsense at 3 and 4 o'clock in the morning, and it kind of falls apart as it goes through Tulsa. This little guy's still hanging on across the I-40 corridor into northeast Oklahoma. Some of these will probably have some hail with them and some wind if this were to verify through tomorrow morning, and that's it. And they're all said and done. Okay, and it doesn't even do anything. Let's see, for Tuesday. Here's Tuesday afternoon. So there we go. It produces a little bit here, little signature here, and that's about it. So they're struggling even to produce anything for Tuesday. All right, let's see where our other one goes. We're just going down the line here because we got to find something that produces tornadoes, right? That's what I've been hearing about for 7 days. Let's go to this guy. All right, I don't think he's going to be in all the way. He only goes out to 18 hours. It just shows the light rain we'll have at the middle of the day that moves through. Did I get them all? We can come back to that one a little bit later, but I think that's about it. Oh, let me look at this one, the NAM here real quick. What time is that? 3Z. No. This is... Okay. I'm going to show you what I talked to you about in my blog, if you read my blog. All right? And this is the only thing that has me curious. So, okay, so what this means is either there's a flaw in every physical scheme of each different of these cam models, which it can't be because they're all built a little bit differently. So I don't think you can have the same flaw carry over because they use different coding. So you'd have to assume there's some flaw that they're not all seeing to be able to erode most of the cap and still not produce storms with the synoptic front drawline combination coming through. So there's something there that's not presenting itself in the data as to why they're not producing storms. So normally they love to produce storms. So the fact they're not, it's curious. So let's go to the European. And normally, the European is not a severe weather model, just so you know that. It's a global forecast model, so just basically rain, yes or no. And this morning didn't have any storms either. It was quiet. And then here, at midnight, 9, 10 o'clock in the evening, it breaks out a few thunderstorms here in northwest Oklahoma, this one and this one. And then at midnight, it has one little here, one here, and some down here. And let's go to 9Z and then 12Z. So honestly, on its face, I'm like, this doesn't look all that impressive. A couple storms that weaken is almost as quick as they develop. But this thing jumps in 3-hour increments. So then I had to do, okay, well, let's do a rainfall total. All right, so rainfall totals will track the whole lifetime of the storm, and that's going to give me more of what I wanted to see. And so this is why I put this in the blog. All right, so you had to use a little bit of your imagination. But this little storm here traveled this direction. This guy here went this one here, hopscotched this one. You had this one here, little baby one here, and a baby one here, and a baby one here. All right, so what this tells me is that the model is at least smart enough to know that these are somewhat supercellular in nature because of the small linear path that they produce with the heavy core of precipitation underneath them. Now, you can try to infer strength with the amount of QPF. So this guy down here in southwest Oklahoma, it's QPF of 0.5 inches of rainfall. This one over here is over an inch. This one up here is, I think, close to 2 inches in some areas. And this one right here is about 3/10 or so. And the one here goes Oklahoma City is super weak, a tenth. All right, so if you were trying to use this as a convective model, you would have to really stretch the output to fit a narrative. Then that would tell me that we would have a weak supercell that went through the Oklahoma City metro area that fell apart as it did so. You had a strong one down here in the south, and you had a strong one way up here in the north. So that kind of jives with prior forecasting of these two areas, and then weakening as it came out of this area. Maybe it is. Maybe there's something to it. And I don't know. This caught my eye just because I'm looking for a model to produce some storms. I'm like, why do I got to go to a global model that's not even supposed to do that? But here's where we are. Okay, so temperatures, like I said, it's going to be cool as we head into Friday, Saturday, and Sunday because we have another storm system coming our way. We're going to get some more rain out of that. I'll show you that here in a second. But temperature's going to be right around 80. Well, I don't know about this one. We'll see. Depends what time that rain starts. If it starts in the late morning across southwest and central Oklahoma, we'll never hit that. Otherwise, we'll be in the 80s after that because it's a model blend. So I don't know which model screwed the pooch and went too warm. But we'll go down here. So Friday, Saturday, Sunday, Monday, those are all going to be into the 60s for daytime highs. Looks like we'll warm things back up in after that. All right, so in the extended, like I said, I talked about the fact that we'll get some more rain in here. So let's go back to the Euro. And I'll show you, we have another cold front coming in. And because our jet stream flow is going to be kind of zonal, which means west to east, it should kind of stall and fall apart. So let's go here. All right, so on Thursday. So the Thursday is when this front was right about here, should start to come in. So this will be during the afternoon. It does produce some thunderstorms out here into northeast Oklahoma, and they kind of back build along that front. Looks like they miss Oklahoma City, and they kind of move off through Arkansas. And this is kind of a linear structure. So you might have pockets of wind with this. This might be like a little bit of a wind damage event. Not on a high magnitude side, but at least one, that's could trigger a few severe thunderstorm warnings. Other than that, that's all it is. It kind of backdoors here to the Red River by the evening. And then on Friday, the front kind of starts to fall apart. We'll get some overrunning moisture coming back in. So you might have additional elevated showers and a couple of thunderstorms late Friday in that same area, maybe along the 850 front. And then as we head into Friday night and the Saturday, then that's when we get a lot more rain. Looks like it's going to start to form along the old frontal boundaries here. So that might be some really good rain. Sometimes you can get a flash flooding event that will occur on a short order of scale of time. So that would be Friday night into Saturday morning. Otherwise, there's Saturday. I know if you had plans over the weekend, not exactly got a good day for that, huh? So all day Saturday looks like a little bit of rain for southern Oklahoma, even central. Then by Saturday evening, it moves out of here as the front gets a little bit of a push, and then things kind of move down to Texas for the rest of Saturday night. And then Sunday looks okay here for Oklahoma as far as rainfall goes. Otherwise, as we said, just a little bit on the cool side. So there you go. I'm going to go back to this one little model here real quick while we were waiting to see if anything updated on this one, if it came in time. Still only 20 hours out. Yeah, it's not going to make it yet. So you can hang with me for a couple more minutes. We'll get the next 4 hours of it here, but it'll probably take about 5 minutes. So let me through some of your questions, and I'll answer some of your questions here. Oh, let's see here. Okay, and also I'll recap because some of you are probably late, so you missed half what I was talking about. By the way, Tiffany, thank you for the stars. I'm going to recap here in 2 seconds. Nikki, thank you. Give my shout outs first. Bryson, appreciate you for the stars here on Facebook. Mary as well. Dante, yep, I was at Channel 5 way back in the day. that I be cooking folks on Facebook. That's right. I turn up the heat. Somebody would say, Aaron, why is your forecast so much different? I could say, well, because I don't bow to a master. I can do my own thing. I don't have to answer to nobody but me and the Almighty. That's it. Everybody else can take a hike, fly a kite. Don't care. But anyway, yeah, appreciate that. But let me go, guys, on YouTube and see if, real quick, I'm going to answer a couple of questions. So that data's still trickling in, so it's almost there. And it's supposed to be our best model. So hang on. It's our super duper experimental, the one that's supposed to replace all of them models. So we'll see how it does. So far, I haven't been that impressed with it. At times, it does okay. At times, otherwise, I'm like, we better keep the others. Yeah, I see Christy there. Make sure you hit the like button and subscribe on YouTube so the algorithms know to keep putting it out there. It's getting rough out there in social media world. You guys have no idea. As a content creator, things have changed. Remember, I've been doing this since 2010, and then the video stuff for live broadcasting since 2014. So I am the original pioneer of all this stuff in the weather world, and I have watched it change so much. I used to blow everybody away because I was the only content, right? And then everybody started doing it, and then I don't have the funding that they do, so they started paying Facebook and YouTube and all this to promote all that content and to promote their pages and everything else. So on the likes and followers, they all blew me away because it's all artificial. For me to get seen, you guys will have to continue to share it, and so that's all organic. And that process isn't rewarded like it used to be. That stopped in 2017, and all of a sudden I went from like this to just flat. And at that point, the writing was on the wall. Facebook told me to boost everything. I was like, I'm not paying you anything. Whatever, man. So we're at a standstill. So if you guys want it to grow, you got to keep sharing stuff. That's basically what I'm telling you. All right, I think that model data might be in here. So let's go take a look. So do what you can. Like, comment, share. Tell the algorithms what's up. Okay, come on. Still not there yet. So close. So this is what we're looking at. I'm at 22Z. Still has the tail end of just all this other light precipitation at this point in juncture. So let me do this here. While this is coming in, I'll look at some of the other parameters. So this is what we call the SIGTOR. In other words, significant tornado parameter, the best ingredients. And right now it kind of favors this little spot here where it's supposed to generate some new storms around 7 o'clock. So we'll see if that does so. A little bit of a hint of something up here. But again, we've had that cool rain and we've got the cap, so that doesn't matter what it thinks at this point. All right. So there it goes. Yeah, there's that first little supercell that's trying to get going way out here. That's along the dry line, that part of the state of Texas. Look how far apart the temperature of the dew point is. See how these lines, how they're not close together? So that puts the cloud base super duper high, which means you cannot get a tornado out of this, but you can get some hail. So there'll be some big hailers out here. Now, as it travels east, it would probably run into a little bit more moisture, but it's also going to run into the tail end of all this rain, which will probably also help stabilize it. So it's a catch-22. And let me go up north, see if anything's in Kansas on this model, and then we'll come back south. So it's the painful part of this whole process is waiting for the data to come in because it just takes so long. There's a lone little supercell out here on this model in far eastern, southeastern Missouri. It's got a very weak, pathetic shear, and basically just a hailer. 1.8 on the ship, so and some damaging wind. So it'd just be a little hail and wind with this guy. All right, come on. It's like watching grass grow in the wintertime. Ain't nobody got time for that. Zoom back in Oklahoma. There we go. 23 hours. Anything? All right. There's the one popping up where I mentioned in those little area of instability. For this one, potential hazard type of a tornado with a higher end of a tornado should one happen. Ship model of 2.1, which means now we're in the large hail over 2 inches in diameter size. But you still have a pretty good dew point depression here, so it'll be hard to get a tornado with this environment. LCL is a little high. It's right on the cusp. I like them to be just a little lower than this, but it's not out of the question since my earlier statement of down here, there'll be mainly hail and wind, but I can't rule out a tornado because it'll be right there. So that's still there. Phil says, been with me since 2014. Woohoo! You have been here for a while. Chad says, what if we don't get rain in the morning? Why you gotta go and jinx us, man? If we don't get rain in the morning and we don't cool things down and we actually hit 80, we do all the things the model says aren't going to happen, then yeah, we would heat things up pretty good, which would be a lot easier to break the cap in that case. And then we would be able to get one. Okay, so this is what I was gonna. That's what I was gonna do. While we're waiting on this, I was gonna summarize in case you missed it at the beginning. So okay, here's your deal. Mark Insco, what do you think about the Con RH? I think I just answered your question. Get me heated. This is where I have to bite my tongue because I don't like con men, right? And I let you know that, so I just won't say nothing. 7 o'clock. There's that storm that goes cross over right around the Red River and starts to fall apart because it's coming into that more stable air. So that jives with everything else I talked about. So far, nothing has surprised me yet on this model. This is a hint here. There might be some convergence doing something in the Eastern Panhandle at the 7 o'clock hour. We'll see if it pops something here at 8 o'clock. We'll get that here in a second. All right, so meantime, in case you missed it, everything, what we did was looked at the whole atmosphere, and we found out that the system was A, late to the party, and it was too far north and west. So we're not going to get our typical afternoon, Katie bar the doors, supercells popping up, all over from the dry line and in western Oklahoma and traveling east, and by 5 o'clock here in the metro, everybody's heading for the hills. We're not having that this time because it's not, everything's all wrong. The system comes in overnight, and usually when it comes in overnight, one of two things happens. One, nothing. Because usually the cap is stronger what the models think, it doesn't erode, and everything's moving too fast, you don't get anything. Or two, you usually sometimes can get some light, elevated thunderstorms that will form. That produce a little bit of hail and wind, and sometimes you'll get a severe thunderstorm warning from the National Weather Service. And that usually happens. On a very rare occasion, you can get a nighttime tornado here in this part of the country. That's more likely across like the deep south, get Alabama, that kind of area. That's usually where that happens a lot more frequently than us here in Oklahoma. It's like every part of the country has what they specialize in when it comes to tornadoes. Ours is more of an old school formula. It either happens that way or you don't get anything. And honestly, the last few years in Oklahoma, we have not had our usual normal supercell tornadoes. You can blame climate change if you want. If that's the case, and you should welcome climate change. But we have had more of those QLCS tornadoes like I talked about, which are along the squall line. But we've seen those increase only because radar has gotten better to detect them. They were probably always there. We just never could see them before. Anyways, we're still having those. We're having low-end tornadoes. We're just not having the big ones, which is fine by me. Nobody wants the big ones anyway. But anyway, so bottom line is the models are not producing storms overnight. And if they do, they're producing that popcorn elevated stuff, which has a little bit of hail with them, and that's about it. So that's as aggressive as they've been. And these are forecast models that are supposed to be able to pinpoint everything, produce supercells if the atmosphere, demands it, etc. The weird thing is that in the atmosphere, according to the models themselves, there should be a small window, a small area where we could get supercells that could potentially produce a tornado. But they're not producing anything in that area. That's the region in western Oklahoma around the midnight hour through central Oklahoma, like around 3 o'clock in the morning. That little sweet spot, basically from like Elk City to Oklahoma City, all right, from like a 3-hour window from midnight to 3 a.m., something like that. Supposedly, the models are reducing the cap. They're bringing in some cold air advection around the 800 millibar layer with the punch of the Pacific front out west to kind of force some storms to go. But yet they don't produce any. So that's an oddity for me because as a forecaster, I would normally say, yeah, we'll probably see a couple of storms overnight as a result of that. And given the environment, yeah, we could have a potential nighttime tornado. So that's what I still say, even though the model says nothing will happen. Because I'm like, imagine if I said nothing will happen, and a couple of things do develop, because I originally thought that, yeah, why not? Because that's the way the atmosphere looks. Obviously, my name would be Mud. So I don't want to go that far on a limb because that doesn't do anybody any justice. I mean, that would be me nailing the forecast, yay. But what's the flip side? I get it wrong, and I tell you there's no tornadoes tonight, then one happens, or excuse me, Monday night, and then one happens, and that's not good. So you can't go that route. So you basically categorize as much as you can, and for me, I just said, very low, and that's what it is, a very low probability. It was already a low probability from the Storm Prediction Center. It was a 5% across the entire area. That's a 5% chance you'll see a tornado somewhere in that region. That's pretty low. And then at nighttime, it's probably less than that. So, but anyway, so that's what we were watching for. All right, the new one just came in. The next run here, 8 o'clock. All right, so this is the 8 o'clock run. These guys fell apart. Again, they came into that stable air. Now, what will happen here in the evening is that the stable air won't matter anymore because once the low jet gets cranking, temperatures come down, but dew points go up, so it kind of offsets from the prior activity during the day. All right, and then also our cap starts to get worked on from the west. So the atmosphere flips to a whole different set of ingredients after dark. But these that were remnants from the daytime don't have it in them to keep going. Okay, so we talked about a little signal what's going on out here, right? So let me see first off what the dew point looks like. Okay, so 8 p.m. Yeah, that boundary is still way out here, so it's not even moving at all. Let's see what a forecast down on the eastern Texas Panhandle looks like. All right, 73 over 65, a little bit of a dew point depression, but the Panhandle can get away with it. For whatever reason, they just have different terrain. And it does have possible hazard type of a PDS tornado with an EF4 category. In other words, you only have it only up to EF5. So the analogs, you combine similar indices with other events. This is kind of how this is a projection of the strength of a tornado, called the effective layer, significant tornado parameter. So it's saying on the high end, if a tornado were to actually occur. Forecast sounding looks, ominous here. Wind of 1.9 and a ship model of 3.6. So if you had these two numbers realized, this would be a barn burner of a storm. This would be nasty. It would have extremely large hail, extreme damaging wind. It would be a nasty supercell storm. The issue here is that the turning with height doesn't occur until you're up around almost 2.5, 3 kilometers. So it's a little linear for my taste as far as getting a tornado to develop, meaning that the storm may kind of struggle to do so. But if it were to do so, it's got plenty of ingredients to go. Anyway, so that's what it looks like out here in the eastern Texas Panhandle, just on a random spot I think I picked near I-40. But the problem is the model, even though it reduced the cap, what was the strength on that? Yeah, basically less than 50, so it's minus 32. So a little nudge, but let me go like this. Yeah, that's what it is. So it basically, if you were to take, so this line here is a forecast line, and that's not going to happen. We ignore that. So we could take the actual 75 and 65, and when you run these two up to read it, it runs just left of my line's too thick, but it runs just the left of this, which is the cap. In other words, it's like hanging on by a thread. So this thread is what's preventing a storm from going. And that may be the case, for some of that data elsewhere over the statewide didn't produce any storms. And in reality, that cap may be just a teeny tiny bit much, just by a hair, to prevent it. Now, if the cap obviously wasn't that strong, then we should get some thunderstorms. Because you can do that on the theta E axis, which is like a warm advection profile, which was supposed to kind of come in this area during the evening and overnight hours in this little sweet spot, which can sometimes trigger thunderstorm development because you have to have a trigger. Something's got to get it kick-started. And if it's not the dry line or a cold front, it's got to be something. If it's an uncapped atmosphere, a theta E axis can do it. So we'll see. Let me see. That's 25. Let's go back into this model's killing me how slow it's coming in. It's painful, ridiculously painful. All right, so there's our crossover. Best shear. Yeah, see, we actually had better shear during the day on this model than we do here in the evening. So I'll show you. So you see these little wind barbs down here? See how you have the red, the blue, the black? You see how much turning with height there is? See, the red was in this angle, the black is in this angle. And that's like a good grief, almost to 9 degrees of turning. If you come up here, where I had pointed that forecast sounding, you have this angle and this angle, and that's like 45 degrees. So the bigger the angle, the easier it is for that storm to rotate and the easier to produce a tornado. So in other words, our shear angles aren't as good here for tornado production as they would be down here in this area. So another limiting factor. And that's why earlier I said that shear looked a little linear for me. Didn't turn enough until later. That was indicative of that and the other one. Okay, let's take a look at the storms. I had 2 more panels come in here. So let's go to the next hour. It popped one up randomly here, which is probably indicative of that theta E axis I mentioned. As that one's forming, it's forming an environment that still has a big cap. This will be an elevated thunderstorm. All right, let's go to the next hour. And it struggles to hold together. All right, let me go to the next hour. All right, so it zips on off to Enid. And in Enid, this is at 11 o'clock at night. Massive cap. Shear is too linear. So if this thing's even going still, it has just this little bit of instability to work with. So a little bit of small hail with it. That's about it. Got some new ones developing here in Stillwater. Probably the same idea. You got one down here in Paul's Valley-ish. Let's see. Big cap here. Linear shear. So this new model here, again, this is supposed to be our prototype, the best we have to offer. It says there's nothing to worry about tomorrow night either. I can't find it. I'm just telling you right now, I can't find a model to tell you there's something to worry about. Not a single one. It is so bizarre. I'm still leery. There's part of me that says, don't you go there. You don't want to commit suicide in the weather world. So, again, I would just say, by the way, thank you, Mike. Appreciate you, man. I would say go to bed with the intention of the following. Somebody somewhere might get a thunderstorm that got rooted the boundary layer, and if it did so, it could produce a tornado. It's not the best odds, tiny odds. Still, it's not 0, so it could produce one. And if that's you, what are you going to do? All right? So if you have, man, listen, have you ever monitored your sleep on your smartwatch or the little rings you can do, and you can track when you go into REM sleep and deep sleep? Now, you know when you're in both of those sleep stages, how waking up is going to affect you, right? So this morning I was in a sleep stage, and there was a dog. This is where you don't know if you're dreaming it, right? Because you hear it and your mind tries to process it, and it puts it in your dream as you're coming out of your dreams. You're really not sure what's reality. And I swear it was a dog getting killed or something. It was the most horrific noise I ever heard. I don't know what that was. Of course, our dogs started going nuts. So then that told me that was real, whatever it was. But I'm still in a stupor as I'm waking up. It takes me 30 seconds to realize what my name is. All right. Now, let's just repeat that, but instead it's a tornado. What are you going to do? Okay, so it's best to have a game plan ahead of time. The whole family, kids, all that stuff. Pets too. Tell them what's up. So it's always a center part of the home. Whatever it is, doesn't matter. Get in the middle. If it's a bathtub, stairwell, find it, closet, everybody pile in there. You can put sporting gear on the kids. Make sure you've got underwear on. Make sure you've got shoes next to the bed, flip-flops, whatever, as long as you have something on your feet. Because should you be in that situation and there is debris around, and you got to walk outside, and there's lumber with nails in it. That's usually what the issue is for injuries. But that way, at least you already have a game plan of what to do. You know, it's up to you as to how soon you can wake up, how much your adrenaline kicks in. But on a nighttime situation, that's kind of how you just have to go to bed. It's almost like you're preparing for war. But knowing that you'll probably sleep through it. So it's a weird place to be, right? Because you got to tell yourself, be prepared, but yet don't be anxious. It's really strange. So when that happens is, what's my role as a communicator? My role is to keep you sane, right? But my role is to keep you prepared. So if I were to tell you there's a 99% chance nothing's going to happen, what would you do with that? Sleep pretty easy? I would. Now, if I told you the 1% chance it wasn't going to happen and 99% that it was, I might pull an all-nighter, just to be safe and just going to work really tired tomorrow. That's just how it works in the probability world. But teeth and bras, folks, teeth and bras. See him read. A fox call, Julie. That may have been it. I don't know. It was early this morning, and little Penelope, she went so nuts. She, we came home at night. She pulled a blanket we put over the blanket. That way it's dark so they don't wake up early. and they don't get woken up or whatever. It's an old trick you learn. Anyway, she pulled the whole blanket through the door and basically knocked the door down. So whatever that was, she wanted to investigate. Jessica, thank you for the stars tonight. Let me see here. That I'm waiting for the next run or the next panel. I'm at 11 p.m. Just so you know, let's go to this one here. So there's midnight. Still nothing out here in western Oklahoma. I'm going to expand this view to Kansas. The front is finally on the move out here. And our winds have all gone southerly. And so there's no convergence along this front. Just the front itself is all there is to get something going. There's a little bit of a meso-low with a little bulge here, but there's no corresponding surface southeast wind response to go with it. So that's kind of pointless. All right, let me go, like I said, to a bigger view because I want to be able to see the theta E axis. And here we go. So this is the theta E axis. So between, this is right about midnight. So the theta E axis is still basically in this bluer shading versus the green. So it's in this little spot here. So in theory, if there's an uncapped atmosphere within this axis, I'll just pick the middle, you could get a thunderstorm to go if there's no cap. Unfortunately, look here, there is still a cap at midnight out here in western Oklahoma. And if one were to go, though, big hail, strong tornado, etc. But not going to happen with that cap in place. So cap is interesting. For those that don't know, cap is basically, we say that term a lot, so if you're new here, it basically just means the lid in the atmosphere. You can't see it, it's there. It's a temperature inversion. So what happens is, if you get to get air to rise like a balloon, okay, so visual this way. You got a balloon in your house with helium, right? And you let it go. What happens? It goes up. And then where does it stop? The ceiling, right? Hits the ceiling in the room and it can't go anywhere. That's your cap. So instead of it being, a piece of sheetrock, it is a thin region of warm temperatures because everything else below it is cold. It's colder. So you need the air as you go up with height to continue to be colder and colder and colder than it was before. Well, if it goes colder, 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 and then it hits this hot spot, it can't go through it. So the cap or inversion is what suppresses the balloon from going through. So if the balloon can't go through, it doesn't matter what's doing it below it, what's helping the balloon to get up. Doesn't matter how much helium you put in it, can't hit the cap and it's going. So kind of mentioned how do you break the cap? Well, you have to force it, which means you have to remove the warm layer, and I can do that by brute force with a cold front that comes in, because that brings in cold air with the whole storm system. Or below here at the ground we live and breathe, I can heat the ground over and over and over, get that balloon to keep cycling, and at some point I can add enough helium to that balloon, aka heat for the air, 80 degrees, 85 degrees, whatever it is, and at that point it's going to be warmer than this layer, and it's going to bust right through. So that's how you get rid of the cap. So if you're a tornado loving person, you want a cap, but you want it to be very, very weak, because you want it to break in a few areas, but not in all areas, because you want the storms to be isolated and far away from each other. That way, nothing can penetrate or contaminate its environment. It has its own special space. It's got its safe space, and it can do everything it wants in that little safe space, which is go to town and not be bothered. Well, if you have a weak cap and the storms go all over the place, well, then they're all feeding all over one another. You got inflow and outflow, cold air coming out, feeding into the next one, and they merge and all kinds of stuff. It just becomes a convoluted mess. So you want a cap if you want tornadoes, but you just want it to be really weak. Now, if you don't want anything at all, you want a super strong cap. That way you can sleep just fine at night. And a lot of times when we heat we get the atmosphere where it's really loaded with ingredients that could produce a tornado, guess what it usually comes with? A really strong cap. It's funny how that works out. There is a yin and yang to everything in life, even weather, even severe weather. And so everything is usually balanced pretty well. If it wasn't, man, could you imagine? We'd have tornadoes all over the place, all the time. Boy, that'd get old, wouldn't it? So, yeah, that's an issue. Somebody said, how hot does it need to get tomorrow? All right, well, I'll tell you how hot it needs to get. Hold that thought. Let's see. Let me go here. Let's go to Oklahoma City, just for example. What was my convective temperature? 94. So we're not going to break the cap. 94 degrees. Now today, we almost hit 94, but we didn't have any moisture out there, so it wouldn't have mattered. That was a dry heat today. You'd have a moist heat tomorrow, and that prevents it from heating up too much. But that's a good question. I didn't even look at that. When you guys, I'll go back here to, let me go back to my storms. All right, so let's go to this one here. All right. Okay, so that is 1 o'clock and 2 o'clock. All right, we have a little cluster going on up here in Kansas. And up here, you know, the models originally had kind of just a very weak cap up there, but then kind of eroding. But they're keeping it tonight. At least this one is, this particular model. So that means these are all elevated storms based off of this guy here. Tulsa. You got a couple storms there just north and west of you, and you have a monster elevated cap. And you have all linear shear. So, all right, this whole model says there ain't nothing to worry about, so I don't even need to look at it anymore. I'm already bored with it. Anyway, that was our best high-resolution experimental model that's supposed to be replacing all of our other models. And because they put all the best of the best into this one, and it's supposed to be the only one we need. I don't know if we're ready for that yet, but looking at it tonight, didn't have anything. None of the other models did. So, again, they all say no storms Monday night, and definitely no tornadoes. Saying that, I still, as a meteorologist, I would not sleep well if I went all in with that and said there wasn't at least a low probability, extremely low, of a potential tornado, assuming a storm can get rooted in the boundary layer and actually develop. Because if that does, there are other indices that would allow that to happen. So, you know, it's hard to assign a precipitation to that other than to say, I'm not going to lose any sleep over it. And I'm the weather guy. Let's see. Ron, yeah, I was done 25 minutes ago. I was done with everything we had to see, and then this new model was coming in, so I thought I'd hang back and talk about it. And didn't do anything different than the rest of them did. So what I'll do is tomorrow morning hours, we'll look to see what's changed, if anything, and then I'll just give you a quick 10-minute live update from my car at work at my lunch hour, and then I'll tell you if either the models produced storms overnight or they didn't. And if they didn't, well, then it's rinse and repeat. You already know the deal. But at least you now know what to do and how to be safe and what to plan ahead and all that kind of stuff. And if you're new and you're already getting worked up, just turn off everything that's getting you worked up. I won't get you worked up, so you can stay here. I don't mind having you. Because this happens almost every other week. We get a threat of storms. So if you're going to get burned out already, you got a long spring ahead of you. So don't let that happen to you. For everybody else, they've already been there, done that. Like, half of them are already burnt out, and the other half are just angry. So don't fall into that if you're a newbie. Just keep cool. We'll be good. All right. I want to thank everybody for watching tonight, as usual. Like and shine. Like and shine. I don't know where that word even came from. Like the video, share the video. I think that's what I was going for. And make sure you subscribe to the channel you're watching on, whether it's YouTube, Facebook, or Rumble, all that kind of stuff. And spread the word. Make this a organic outreach. Let it continue and build. So it's one of those deals you can pass it forward. You know, hey, do an act of kindness. Really, it's all it takes. How simple that is. So there it is. All right, you guys have a great rest of your night. And thanks for tuning in, and we will talk with you tomorrow. Take care.